In these two examples, we're going to be doing some antiderivatives of some trig values, and trig values get a little tricky. So it's all about, and just don't forget that trig values have a tendency to be use substitution, or sorry, have a tendency to be chain rule types of problems. And so to undo that, you have to use substitution. So the trick is always trying to figure out what is your u, right? Is my cosine the u or is sine the u? It's going to be one of them. So here's what we want to do. I'm going to rewrite this more like cosine of x to the third power times sine of x dx. Okay, so anything that's on the inside of something raised to a power, almost a guarantee that that's going to end up being your u. And so here's my other little piece to this is that if I let cosine be my u, and if I do the derivative of that, I should have its derivative somewhere else on this problem. And so if I do the derivative of cosine, I get a negative sine x dx. And that sine is right there. In fact, sine x dx is right there. So I can sub that out. However, I don't have a negative on it. So let me rewrite it one last time as a negative du is going to equal a sine x dx. So here's my next piece is kind of rewriting things to make things a little simpler to work with, is that I took cosine of x and I'm going to be replacing it with u. So that's going to be a u to the third. And this whole sine x dx gets replaced with negative du. So negative du. And that is actually what I'm doing the antiderivative of. Much nicer. So I do the antiderivative of this, get your negative, we add a power, divide by that power, plus c, and then I can sub my cosine back in. So it's a negative 1/4 cosine to the fourth x plus c. All right, and the hint kind of on this one again was rewriting it like this, and then it's almost always whatever's in that parenthesis. There's part of the chain rule because you're going to be doing the derivative of the inside, getting the outside. That's going to end up almost always being your u. All right, now this one, trickier. So you don't have that, but you do have a cosine cotangent, which if you remember, if we take the, is our hint here. And if we cut out the p on that, the derivative of secant is secant tangent, the derivative of tangent is secant squared. And then I can turn this into a cosecant cotangent. And I apply a negative because the derivatives of cos are always negatives. So derivative of cosecant is negative cosecant cotangent. Derivative of cotangent is negative cosecant squared. Well, you're sitting with the cosecant cotangent. So the antiderivative of this is going to be cosecant, maybe with a negative on there. The tricky part is this x squared's on here. And so what I see out of this is I have this extra x on here that's not really part of these. And that is actually us taking the derivative of x squared and getting an x. So our u value is actually going to be the x squared piece. So our du is going to be, put it over here a little further, I might need the space. So our u is x squared. Our du is 2x dx. I'll pull the 2 over, so it's a 1/2 du equals x dx. And what you would find is that if you were to take u, or let's say cosecant as your u value, then you do the derivative of cosecant, you're going to get a cosecant cotangent, but you've already taken the cosecant out, so then you're missing a piece, right? So you may have to play with it to kind of get comfortable of what is my u, what isn't my u. So if I start to sub some things here, I have an x dx, so let me actually rewrite this one time. That if I rewrite this and do a cosecant x squared, cotangent x squared, and then if I pull the x to the end, that lines them up perfectly. So I can sub out that piece with a 1/2 du. And to be honest, if you have anything other than just an x inside your trig values, there's a good chance that that's going to be your u value. Just kind of something to look for as you go through it. So if you have a 1/2, and then we'll put the du in for that. And then these pieces, it's the x squares that we're replacing with u. So we're looking at a cosecant u, cotangent u du. So now we go back to this, that we took the derivative of something and got a cosecant cotangent. We would have taken the derivative of cosecant and got a cosecant cotangent, but we need a negative on there. Okay, because this turned into be a positive, so we need to negate that. So we're going to have a negative cosecant u. Let's see. And then we'll rewrite our stuff back in. So this negative we can apply to the 1/2. Negative cosecant u is x squared plus c. And so if I quickly kind of double check that this turns into this when I do the derivative, if I were to do the derivative of cosecant of x squared, derivative of cosecant is negative cosecant cotangent. So the negative would cancel that negative. I'd pull in a cosecant cotangent of x squares, and then times the derivative of the inside, which would be 2x. So there's the x, and the 2 would get wiped away because of the 1/2. All right, so there were a couple different trig problems, and they just kind of take some exposure and practice to figure out what values do I need to be subbing in for my u's.